be like Mario.
Hey, you know why? Hey, do you know why I initially decided to do my septic? Because when I contacted everybody in May, they're like, oh, yeah, I'm about a month out. I've been waiting months, and they won't come. That's how much work there is.
Because they hate you.
No, they hate fixing it when they can just go to new construction and do it themselves. I mean, they can do it from scratch and it's not dirty, right? So my point is, there's so much work out there, they can charge you anything they want, and they can just ignore you. At least now. I mean, if the economy goes to crap and the housing industry falls apart. But the housing industry was so bad from like 2007 to 2012 that there's a shortage of housing because they didn't build for so long because banks wouldn't loan money and all that stuff. Anyway, yeah, they wouldn't come. So that's why I started doing it. But don't worry, it wasn't dirty like you're thinking. When your septic's broken, stuff's not flowing. I don't know why I'm videoing this now.
Really broken.
And mine was really broken, like it just. And I actually have a really great septic. It's high maintenance, but it's they put them in national parks. So by the time everything runs through most people's septic, I don't know if you know what it is, but there's like a chamber for solids, and then a chamber for liquids that flows, the liquids, and then it runs out underground into these lines, and it just absorbs into the earth, and the earth's a great filter. Mine goes through this peat system, and the peat filters it to 95% purity. It's not drinking water, but it's 95% pure when it comes out of there. So when it comes out of there, then it goes into these gravel beds underground, and I was just creating new gravel beds underground.
Is it really good start to the video?
So anyway, little lesson on
Septic.
what's it called? Even flow septic systems. Anyway, okay, so back to what I'm getting paid for, which is not a septic lesson, but back to AP calculus. We're jumping back into slope fields again, and we've already, me starting the video, talked about how this is a great match for this, because as we learned the other day, this is the only one that has an X in it. And if it only has an X in it, that means Y does not affect the slope of the field. So at any value like X equals 1, I should have the same slopes, or X equals 2, the same slopes. You can't say that on any of these other values. At 2, you can see the slope is changing. At 2, the slope is changing. All of these, slope is changing. So that was a really quick way to say that C must go with the 5 there, or V if you're not into Roman numerals. Okay? Now the other ones are going to be a little bit more of a challenge. And again, don't make mistakes by going like this. Oh, look at that. That's a parabola. Parabola must be going up. Y squared.
No.
Right? Or maybe, oh, it's going to the right. Because remember, this is talking about slopes. Now the problem with these 4 that are left, they only have Y in them. And if they only have Y, that means for any Y value, the slopes must be unchanged. Now that's true for all the remaining ones. For any value of Y, like Y equals 2 or Y equals 4, slopes are the same. So there's no help there. But there is some other help if you start thinking. Now the bottom line is this, on your test, I was looking over your test, or what I'm going to give you for your test in a week or so. When I was looking over your test, there's a lot of slope field problems like this, little problems. Be careful because there's no partial credit on these. It's like 3 points, right or wrong. Right? So bottom line, all you have to do is just check enough points. Like for instance, right here, at 1, 1, the slope looks about like that, which is maybe 1, maybe 1/2, I don't know. So I could plug 1, 1 into all of these and see if I get a slope that's about 1, 1/2 or so. Here,
1.
I get -1. Well, there's no way that works there. So there's no way that 1 goes with that. Now here I get +1, okay. Here I get +1, here I get +1. But at least I eliminated A from the discussion on this problem. Now, pick another one that has a different slope. How about 1, -1? That slope looks like it's -1, right? Ish. Well, if I plug in 1, -1 into this, this, and this, I should get a negative slope. Here, what do I get? -1. That might be it. Here, what do I get? -1. That might be it. Here, what do I get? +1. That's impossible. This is negative. That would give me a positive. when y is -1. So that eliminates this one. Now you're down to these two. And literally, this is the process I go through on these. So there's work to be done. And a lot of people, man, it's just they get sucked in by the first thing they see that's right. They check one point and they're like, oh, that must be it. Make sure you eliminate everything. And also, give yourself the realization that you might have made some careless errors. So really be careful. Okay, so now how do I determine that this is either B or D? Well, how about this? What happens when y is bigger? Like what happened at y equal 3 right here? At y equals 3, 1, 2, 3, or even y equals 4, what is the slope doing? Getting what? Getting bigger. So if y equals 4 here, what's the slope doing? Getting flatter, right? Or smaller. So y equals 4 here makes sense. So I'm going to check another couple extra points to make sure. So at y equals 1, 2, 3, 4, 5, 6, that makes sense. At y equal -1, -2, -3, -4, -5, -6, that makes sense. What about y equals 0? 0, that makes sense, which this doesn't. Y equals 0 here should be undefined. But here you have all these little slopes running through there. And you can see that it's going to 0 also. You tracking with me?
Tracking.
So right here, this must be Roman number 1. All right, what about, let's check out this one. Any ideas?
It's the opposite of that, it's supposed to be A.
Say it again.
It's like, it's on the X. So it's on the X-axis, so it should be A. And the slopes are the other way, so it would be negative.
Yeah, so it makes sense to me based on what I just did. Everything here, I'm just negating and putting it here, right? So it looks like all the slopes are just the complete opposite of these. Where this is 1, this is -1. Where this is 4, this is -4. So to me, I look at this and I go, oh, 2 has to go with A, right there. Now there's another thing I can do. Look at E. What do you know about the slopes at E? Because you're squaring it. They're always going to be positive. So there's not a single possible way. These are little things that after you've done a lot of these, they will be popping into your head more quickly and it'll make it a lot easier for you to do these. So right here, I've already eliminated 1 and 2 and 5. Is there any way that this could possibly be the solution to this?
No.
But it's a parabola. And people get sucked in with that kind of stuff. But right here, you can see these are negative slopes. These are positive slopes. There's no way slopes can be negative based on this. Well, let's look at this one. This right here has nothing but what? With one exception. I said it always is positive, but it could be 0. Right, when y is 0. But look at this. When y is 0, it's 0. But every other slope is what? Positive. So E must go right with 4. Are you with me on this?
Tracking.
Okay. All right, now, did we do this one?
Me too.
Let's think through this. What is this saying? The bigger the value of y, the slope starts approaching 0, right? And look at this. Slope was like 1, a half, a third, a fourth, a fifth. It's getting flatter and flatter, approaching 0. What's the slope when y is 0? What is it? This looks like this parabola is doing this, or this curve is doing this, right? So right there, what is it? Undefined, and sure enough, when y is 0, that would be undefined. So 3. Anyway, don't rush these. Take your time. It's so easy to miss 15, 12 points on these, and I'm just like, ugh. You do all this hard work with differential equations, and you miss a problem like this because you were careless. All right? Check out this one. Match the slope fields with their differential equations. Now, if I was doing this, I'd probably go through first and say, well, there are a couple that only have x's, that one and that one. So that means no matter what x is, the slope should be the same along that whole vertical. So right here, do I see the slopes the same here? Nope. Here? Nope. Here? Nope. Here? Yes. Here? Nope. Here? Yes. And at that point, it becomes pretty easy, right? Because you look up there and you're like, well, the only two are sine and x. That's what's the derivative of a, I mean, if the derivative is sine, it came from a what?
Negative.
A negative cosine? And sure enough, look, there's a negative cosine curve right there. So it's pretty easy at this point to say, okay, 4 must go with this. And then the only other one that had a vertical property like that was 6. And you can see that right here. Also, how hard would it be to differentiate, I mean, to take the differential equation and take this differential equation and solve it? If I move the dx up over here, what happens when you integrate x dx?
X squared.
X squared. Look, so the actual equation should look like a parabola. Doesn't just look like it would represent a parabola equation. But again, worst case scenario, you could always come in here and plug values in. The bigger the x value, the bigger the slope. When x is 0, slope is 0. The more negative the x value, the more negative the slope. So that all that mentality works pretty great with 6. All right, now what about the other ones?
E is probably 3.
You say E is probably 3. Why do you say that?
Because it's the only one that varies from x and y.
See, that's a great tool he keeps bringing up. I have x's and y's in there. So that means the slopes are affected by both. Look at this. Are the slopes the same right here? Yeah, so y values of any y value, same slope. Any y value, same slope. Any y value, oh, we've already done this one.
C.
We've already done 4 and 6. Okay, any y value, same slope. The only one that doesn't have that, that's actually different on the horizontal and the vertical, is this one. That's the one that affects x and y. But just to go ahead and make sure you're okay with it also, what's another property you can see about this? What happens when x and y are the same?
0.
You get a 0. And if you look up through here, 1, 1, looks like it's going to 0 there. 2, 2, looks like it's going to 0. You can see this thing going to 0 at 1, 1, 2, 2. Also at negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. Well, you can see those zeros in there, but check enough points to be completely confident. All right? And then these problems do not end up being difficult when you can do that. Now, the rest of these have y's. I think 3. How do we make sense of them? What about this? What do you know for certain about A?
It's going to be some slopes.
There's no way to make it negative. It's always going to be positive, right? And the slopes are going to get bigger. But if the slopes are always positive, when you look at the remaining, that can't be it. That's got negative slopes. That can't be it. That's got negative slopes. This is the only one that has that as an option, right? And the bigger the y value, the bigger the slope, right? Smaller the y value, doesn't matter. Still big slopes, even at like negative 10, negative 20. So 2. And then these, we already did this one, I think, didn't we? When y is 0, 0. When y is 1, y is 2, y is 3, y is 4. Y is negative 1, negative 2, negative 3, negative 4.
You just look for a shift though.
Sorry?
Look for if that one graph is y equals, or dy dx equals y, then the dy dx equals 4 minus y. Just shift it up 4.
What's the negative y do?
I mean, reverses it.
Yeah, and you can start using rules like that. I'd be a little bit more careful because it's not always going to behave that way. You're kind of intermingling your rules for graphing a line with graphing a curve, with a differential equation. So I'd be a little bit careful. But right here, a quick check real quickly is, what happens when y is 4?
0.
So you should have zeros at y is 4, and sure enough, the whole graph is going to a 0 right there. And then anytime you have a y value smaller than 4, what is your slope? Positive. All these are positive. Any y value bigger than 4, negative. So anyway, being careful. Again, I talk about these and people roll their eyes. They're like, we got it already. And then they miss them like crazy. You've got to slow down and be careful. Don't jump to conclusions. Okay, so yes, that would have been. All right, this is a little bit more like the AP test. and a little bit more like mine where it's not a matching situation, I just give you one curve, and this curve is all over the place. Some kind of crazy little spiral going on. And look at the answers. They all look very similar. You've got to slow down, and before you choose what's right, you've got to eliminate everything else, and be careful. It's easy to make careless errors. Anybody have any idea where they'd even get started?
Just start plugging in values.
Yeah.
You look for an arrow on A and C, when they're like, there'll be places where it'll be undefined.
Okay.
And they're null.
And somebody said 0, somebody said undefined. Those are usually what I start looking for initially. So if I look at these, I see zeros. Looks like zeros like that. What do those points kind of resemble right here?
Y equals negative x squared.
Okay, so what do you know about those? Right there, it looks like when the x's and y's are opposite, like at 1, negative 1. At 1, negative 1, I get a 0. At 2, negative 2. At 3, negative 3. Where could that happen?
With
The top is x plus 1.
Yeah, when the top has an x plus y. 1, negative 1. 2, negative 2. But right here, 1 minus a negative 1, that doesn't give me a 0. So I can see along that right there that this isn't going to work for me, and this isn't going to work for me. But don't just, you might have made a careless error. Double check before you eliminate. Especially if you have time at the end, go back and double check values. Okay? What about, where do you see zeros occur? Looks to me like I see undefined. This thing looks like it's kind of curving like this and going vertical.
So undefined is just going to be a vertical line.
Undefined normally is, this is your calculator. Most AP problems, undefined is nothing. Like there would be nothing there. But even if there's nothing there, I mean, even if it just gets really super steep there, like you can see this thing coming in like this and then turning. At some point in there, you can see it, that turn is undefined. So just very, very steep could represent really close to an undefined, even if there's nothing there, or the idea that it's doing that. But we're going to check other stuff. But anyway, what do you see here then? These are what kind of values?
Y equals x.
When y and x are the same. Where do you see y and x are the same working out for you? Like at 2, 2, 2 minus 2 is 0, that's undefined. At 3, 3, 3 minus 3 is 0, that's undefined. So that's more confirmation that either of these are going to work for us. But right here at 2, 2, 2, 2, no, you're not getting undefined there, are you? So now at least I've got confirmation that 2 different ways that these can't work for me. But let's go back. We got to do better than that. We got to figure out which works. Anybody got any ideas?
See if they're negative or positive.
Pick some random values. So how about we'll start with at least something that I know the answer to. What does it look like, say at 6, 0, the slope is? If you can see that.
A positive number.
Okay, so right here, if I plug in 6, 0 here, and I plug in 6, 0 here, here I get positive 1, here I get negative 1. That's a positive slope. So that check right there told me I don't think that works. And I'd get rid of it. But just to be safe, let's pick something else. What about over here at 4, 0 or 3, 0? What it looks right there that it's definitely a negative slope. So I'm going to plug in, I'm sorry, not 3, 0, 0, 3. So 0, 3, 0, 3, 0, 3, 0, 3. It's really easy to be careless. All right, so double check them twice to make sure. But you can see right here I get 3 over negative 3, which is negative 1. That still makes sense. Here I get 3 over 3, which is positive 1. That doesn't make sense. Okay, now I'm really confident that's it. But if this, like we just showed a lot of work there, is that going to make any sense to me when I'm grading your paper? No, it's right or wrong on these guys. And if you jump the gun and you're a little careless and you don't double check, I would literally try to eliminate problems like this with 2 different points. Because if you just do one and it's careless, it's very easy to go -3, -4, -3, -3, whatever, and all of a sudden you're getting hammered on this test because of the doable problems that really just take some time and being careful. Anybody got any questions with that yet? All right, what about here, match? This is just more, oh yeah, this is actually pretty good though. Okay, on this problem, is there anything about these, the A, B, C, D, that, about the A, B, C, D, E, F, that's bothering you? Look at them. Consider that you're about to plug numbers into these differential equations.
Like E.
You don't like the E's? You know what? I don't really mind the E. I just don't like the negative exponents of the E's. Now, if you don't like E's in general, just remember, put a 2.7 in, put a 2 in there or a 3 in there. All right? The thinking is the same. So if you want to think of that as 3 to the negative x, look at that. I mean, this is pretty vague, right? Do that. But if I were you, I would, and you're bothered by the negative exponent, I would change that so that you have a better understanding of what's going on. So like right here, if you want to rewrite that as x over e to the x, this as x squared over e to the x, this as 1 over e to the x squared, and this as 1 over e to the x. Do that if it helps you think better. Are you with me? All right, so let's check it out. Anything that you want to jump, they all have nothing but x's. So there's nothing we can really eliminate real quickly like that. Is there anything else that we've talked about today that might help you?
The sign is probably should be easy.
The sine and the cosine? Okay, clearly these are the sines and cosines, at least I think clearly. Which is which? Because this is a mistake a lot of people make.
They're
Oh, right here, just kind of went up and down,
It's the opposite.
right? And they go, oh, it looks like a cosine, must be C.
No.
That's not right though, right? Because these are differential equations. Now, if the problem had been y equals, then yeah, you might have something to go with. But it's not, it's slope equals. So, you could say, oh, it must be opposites, but be careful because I could totally give you 4 that look like this and say which one goes with that. And they all have a similar look to them. So check some values if you're not sure. But yes, on this one, it's just matching. So definitely, the sine looks like it does not go with the sine one, but the cosine one. And the cosine looks like it goes with the sine one. But just to be careful. All right, everybody know their unit circle? And if you don't, you really need to review that before you come in here. But what's the slope right here?
1-ish.
Okay, so that means when x is 0, which I only have x's to deal with, I should get a slope, a differential equation value of 1-ish. So plug a 0 in there. What's the sine at 0 radians?
0.
Sine means y value. It's 0. That doesn't work for this. What's the cosine at 0 radians?
1.
That's 1, right? So it makes sense that 2 would go with C right here. And then by default, by default 1 would go with that. But check some values like that just to make sure. Because haste is what really kills people on these problems. All right, what about anything else? I got something that I kind of feel good about. Is there any particular one of these that can or cannot give you negative values? Now, for the record, can an exponential function ever be negative? No, not unless there's a negative in front of it. Because e to a power, it might be big, might be small, but it's not negative. So when I look at this, the denominators of all of these cannot be negative. And the numerators of this and this and this are either already positive or can't be negative either. So what's the only slope out there that can even have a negative slope? A. If you get rid of sine and cosine. And when I look at this thing, look at that. For every negative value of x, what do I have here? Negative slopes. And when x is 0, what do I have? 0 slope. And then what happens when x is like 1? Well, 1 over 2.7 is pretty small. 2 over whatever 2.7 squared is, 8, pretty small. 3 over that. So you can see the bigger I get out here, the smaller the slope is. And I know that on this graph, it almost looks like it does this and this, but that's your calculator. I picked better problems for your tests. So to me, 3, it's got to go with this. Now I'm down to the last 3. Anybody got any ideas? How to differentiate between one and the other?
For E and F, as x approaches, when x is at 0, the slope is always 1.
So for E and for F, when x is 0, the slope is 1. And the slope would be what? 0. So the remaining 3 at 0, I got a 0 there, I got a 1 there, I got a 1 there. So these two could be 1. That makes sense for that one and for that one. But this one at x equals 0, that would be a 0, isn't it? So it must go with this right here. 4. Now I'm down to these two. How am I going to figure that out?
Just look at the degree of the slopes, if it's sharp or not.
So, because it looks like it's the same as you head to the right, very close to 0, right? And that makes sense because like at 10, e to the 10th's a big number, e to the 100th's bigger, but I mean, they're both so big on the bottom, the top's 1, they're going to look very flat. So you can see that they are both very flat as you head to the right.
If you are doing like a negative exponent, like in 6, then you're going to end up having like a vertical line because it.
Y'all see that?
connects the top.
He's saying if I plug in like a negative here, in fact, you're back to having a negative exponent, so why not just plug a negative in there? If I plug a negative in there, what happens? E to the, like say I plug in negative 6. I get e to the negative 6 or e to the 6th. That's huge. So at negative 6, I ought to have a huge slope. But over here, what happens if I plug in a negative 6?
It's just going to be like flat.
It stays positive because you're squaring it. So I get e to the 36th, and 1 over e to the 36th is really small, close to 0. But again, what am I really doing? I'm using a little intuition, but at the end of the day, I'm plugging points in. If you have any issues, if you show up on test day and you're like, man, I haven't done slope fields in a couple days. I hadn't done my homework all week, all 2 weeks. But I could, if you try to remember these little rules or these intuitions, you might come up empty, but you can still plug in values. Just plug in enough of them. But yes, so this right here is going to 0 right there, 5, either way. This one's going really steep, 6. All right, so we're going to jump into this, and we're just going to do a bunch of these. And I believe, if I'm not mistaken, George, can you give me some light? Yeah, I said begin the teaching series problems. We're going to start with them in class for the remaining 13, 14 minutes. We're going to start just doing differential equations. I know some of these you see BC at the top. Your AP test will be the 2/3 of it will be the BC test. So they pick a random 2/3 to make the BC test, and then they add an extra third. So they'll actually get a sub-score. Like if you really stink at the BC part of BC Cal, they'll go and grade the 2/3 that's AP-like, and they'll give you a sub-score. That way, if you fail the BC part or the BC test, you might still actually pass the AB test and get some college credit. So they give you an opportunity for that. And that happens occasionally. We have a couple times the kids will make a 2 on the BC test, but they'll make a 3 or maybe even a 4 on the AB part, and they can still get some college credit. So if you see these, don't go, oh man, they're harder. No, that just means they were the same on yours as they were on theirs. Okay? Which begs the question, why didn't I just use the AB one? I don't know. I didn't make this teaching series. I borrowed this from somebody, or these problems. So right here, what are they telling you right here? It says the differential equation is this, and if y is 1 when t is 0, what's the value for t, which would give me this? What does it sound like I'm asking you to do? What do we call this process? I am going to solve or find the general solution, which would be solving, right? You're going to solve the differential equation. So what do you do again to solve?
move everything to their corresponding places.
Now, you're gonna bring down a negative 2y or just a y?
Just a y.
Yeah, because you don't need to bring them. You can still do it, but it just makes more trouble moving down the road. So I'm going to divide both sides by a y to get dy over y. And I'm going to multiply both sides by a dt to get negative 2 dt. And I'm going to integrate. How do I integrate a 1 over y dy?
It's natural log of absolute.
Natural log absolute by y. And how do I integrate that on the right? Put a t in there and multiply by a t plus c. And then, and by the way, you would get 1 point. Actually, multiple choice, you're just going to get 1.2 points for getting that correct on the AP test. Work doesn't even matter. So feel free to be as sloppy as you want on a multiple choice question, unless it's my test. And on my test, I still grade it. I'm just making the multiple choice to give you practice, but I still grade them like a free response. So what am I going to do next? Exponentiate both sides, right? And that gives me absolute value of y equals what? Swing the c, good. E to the negative 2t. What does the absolute value do? Creates plus or minus, but the c eats the plus or minus on these. Not every problem starts with a c up front, but these did. And then now I got to solve it completely, but they gave me a point. When t is 0, y is 1. If I plug, and I always label what I'm doing here. I'm plugging in the point 0, 1. And when I do that, I get 1 equals ce to the negative 2 times 0, which makes c1. Great. Now I'm here. And then it says, what's the value for t if y is a half? So what do I do to solve if y is a half? So I plug a half in for the y. And what would you do to solve that?
Natural log both sides.
Natural log both sides. When I natural log both sides, I get ln of 1/2 equals negative 2t, and I divide by a negative 2, and I'm glad this came up. So there's my t value. Where is it?
C.
Oh no.
You think it's C? I think it is C, but I think it's dirty. A lot of people go, oh, crap, I don't see it. Well, that's got a negative in there. I guess I'll go with A. Because you don't understand your log rules. But what is the log of a half? The log, natural log or any log of a half is either one of two things. You can think of it as ln1 minus ln2. Remember that rule? Two logs being subtracted, you combine it to one log by dividing. And what's log of 1? 0. So that gives you this. That works out great. So if I change that to a negative ln2 over the negative 2, there's my C. What's the other way I could do it? What's 2 in the denominator the same as? 2 to the negative 1? And then don't you have a rule that says you can swing that negative 1 up front?
Yup.
So that's another option for you to do that replacement. AP almost every year does this. I don't know, there's just a fascination they have with log of a half is negative ln2. Do you know that? And you do all this work and you miss it because you don't. Now you would be okay in my class because if this is a 4-point problem, you'd probably get 3 or 4 for just if you could get to that. But make sure on the AP test you're going to lose everything on a multiple choice question that way. What about this? At each point on a certain curve, the slope of the curve is 3x squared y. If the curve has that point, then what's its equation? What does it sound like you're doing?
Finding a general equation and solving for a specific one.
So finding the specific solution, but ultimately solving the differential equation. So that means if the slope is this, then dy dx is this, right? So, because that's what slope is, dy dx is. What would you do?
Move everything over.
So what am I doing for the y?
dy over y.
So dividing by the y gives me dy over y. And then what are you doing with the dx?
Times 3x squared.
Multiplying both sides by dx, giving me 3x squared dx. Now, when I'm looking at this right now, there are certain things I'm going to rule out, but sloppy people right here, Oh, I bet it's b, because when I integrate this, I get x cubed. It's got to be b. It's got it. But you're not taking into consideration that this is 1 over y. So what happens when I integrate? Now I do get 3x cubed over 3, which is x cubed plus c, but then you e. And when I e, I get c e to the x cubed. Now at this point, everything is gone except for c C or A. But if I have the 0.08, what ends up happening? When I plug 0.8 in there, right? I'm going to save myself the trouble. C is 8, and at that point, I'm feeling pretty good about A. As these are test questions, as you can clearly see, and they're not all antiques because I save a lot of the newer ones for like when we actually start practice tests and stuff like that. But you can go through, and there's every single year, simple little 1.2 point problems. That's what you get for the multiple choices. Let's find something a little interesting. Oh, what about 3? Does that look interesting to you?
Yeah.
Check it out. What are you going to have to know? Or do you know? You don't. I was hoping you'd have to know something about this, but it's not that tricky. So look at this one. Got to separate our variables. So y's got to come down, dx up. Integrate. Once again, ln absolute value of y. What's the integral of secant squared? Tangent x. Right, because if you take a derivative of a tangent x, you get secant squared, so an integral of a secant squared gives you back the tangent x. Plus the c, and then again, e both sides. And you can probably start scanning right now. It's, if I'm doing a problem like this, it says when x is 0, I'm going to bring this up. Y equals ce to the tan x. So it's not going to be a. It's not going to be b, because you look right here. It's going to have to be c if it's going to fit this model. But sure enough, when x is 0 and y is 5, c ends up being 5. You can do the math on that if you want, but.
What did you think it was going to make it through? You said at the beginning.
Honestly, I thought it was going to be ugly and require some inverse stuff, but I didn't really think very far into that. Look at number 4. Okay, so we got exponential growth and decay. Maybe when I start seeing bacteria, that's immediately what I'm thinking. But let's just keep reading and see if that actually makes sense. So right here, bacteria in a certain culture increase at a rate. What does that mean? What is that statement saying? Bacteria increase at a rate.
The derivative is.
The derivative of bacteria is, right? Because it's the rate at which it's increasing, or the rate at which it's changing. So you can call it anything you want. If you want to call the amount of bacteria B, go ahead. If you want to call it Y, go ahead. So I'll use big B. The rate of change of the amount of bacteria is proportional to the amount of bacteria. Is proportional. What kind of proportional? I guessed directly because it didn't say otherwise. Times B. So dB dt equals kV. Is that a special relationship that we talked about? Yeah, a ton of times. So for you right now, you could say, oh, well then B equals CE to the KT. And if you're using Y, use Y. Just don't use B's and Y's. So it says if the number of bacteria doubles in 3 hours, how many hours will the number of bacteria triple? Now, we learned a shortcut. They didn't give me really a point, did they? But we learned a shortcut to finding K. Can you use it here?
Yes.
It says K is always what?
Ln of the rate over the t.
That's right. And I use this when I know really specific rates like doubling or halving. So it says that I double it in 3 hours. double it in 3 hours. So if that's, and it looks to me like this is a non-calculated problem, I guess. Since there's no decimals. So if that's my K value, let me just go ahead and plug it in there and see what happens. Now it says, in how many hours will the number of bacteria triple? Well, how many bacteria did you start with?
1D.
Hold up, how many? I haven't looked at my key, so I don't know if that's right or not. But how many do I start with? What is always that amount that I start with end up being? C. This is my initial amount, right? So if that's my initial amount, what does this end up being? How many hours will it take this to triple? What could I put in this? This is the final amount, isn't it?
3D.
So put 3C. Because if that's my initial amount, heck, on these problems you could really pick any amount you want. This says this works for any amounts, right? You want to make the initial amount 10 and that 30, knock yourself out. 10 and 30, when you divide by 10, you're going to get a 3. I'm making it C and 3C, and when I divide by C, what do I get? 3. Does it really matter what I choose? Does it? No. So we got a couple seconds. What would you do? It says how many hours? Natural log both sides, and I get ln 3, and that goes away. And then what do you do to solve for t? Multiply by a 3, divide by an ln 2. Do you see that?
Move the 3 in the exponent, just make it a 1/3, and you cancel the d and the L.
Yes, you can take that and make it a 1/3 of that too. It's not going to match anything. At the end, you have to kind of re-manipulate it, but yes. Initially I thought no, because the growth rate would be, no, if it's the same culture, yes, because the K value is the same. So, yeah, it's going to be the same K value when you're tripling apart. So, yes, K is always proportional that way. Yeah, absolutely. Yeah, that actually makes a little more sense, actually. And that stinks being Daniel and having to come all the way over here.
Oh, God.
Clear. Yeah. Off my game today.